Okay, so in this video we are going to set up the navigation for the Turtlebot 4. First, in the last video, I mentioned to do something to sync the time. It's more effective if we reverse the rules of it. So what we're going to do on the user PC first, we're going to switch to the FAU network. And then once it connects, which we can tell from this, we're going to type in sudo system ctl restart crony and then crony d. And then after a few moments, the time up here should update to whatever the current date and time is. And then we're going to switch back to the robotic application network. And then once the indicator goes back, we're going to edit the file for the configuration for Crony by doing sudo nano /etc/crony/crony.conf. We're going to scroll down and we're going to do two things. We have to undo what we did last. We can comment out a line by putting hashtag, or you can just delete the line. Then under it, we're going to type in allow 192.168.1.0/24. So we're going to save it by pressing on the keyboard Control X, then Y, then Enter. Then we're going to restart the Crony and Crony D again by running the same command. Okay, so now we need to update the files in in the Pi and in the Create 3. So we're gonna SSH into the Pi, which is going to be SSH Ubuntu at 192.168.1. Whatever your robot number is plus 10. So mine is 51, so I'm doing 61. Okay. The password is Turtlebot4, all lowercase. Okay, I might have typed it in wrong. Okay, so now that we're here, we're going to edit the configuration file with the same command we did before. And two things. Over here, underneath the allow, we're going to remove or comment out the second one that we allowed for 192.168.1.0/24. And then we're going to add in this line where the last three numbers should be whatever your robot number is plus 110. So my robot is 51, so I'm putting in 161. And we're going to save this by pressing Control X, Y, Enter. And then we're going to restart the service by running sudo system ctl restart Crony and Crony D. Okay, so once we've done that, we can confirm that it worked by, after a minute or two, pressing date and making sure that the time matches. Alright, so now that that's done, we can exit out of this. And now we have to update it for the Create 3, right? So in the URL, in the web browser, you're gonna go to 192.168.1. Whatever your robot number is plus 10, so your Raspberry Pi's IP address, :8080, which goes to the port 8080. And then we're going to go to here, and we're going to press Restart NTPD, and then press OK. This will take a couple of minutes to do. Once we're done with this, we're going to start working with the navigation. And we can check that it worked by going to beta features, set date and time, and make sure that the time matches. The time might show a few hours ahead because it's in UTC. Right, so we can close out of all of these now. Sorry, that was from the last demo. And now we need to start running the navigation, and we can do that by first opening a new terminal and double checking that mouse to topic list shows the two things that you need to make sure that both the Create 3 and the Raspberry Pi is connected. If you look at battery state and command velocity, that's the Create 3, and if you look over at HMI, buttons, display, and all of those, that's the Raspberry Pi. It's not just Raspberry Pi, it just shows that the Raspberry Pi is connected. So first, I'm going to give you a warning now. This might be a little bit tedious, and you might have to run some of these commands again. But we're going to start by running ROS to launch Turtlebot 4 _ navigation slam.launch.py. And after a few moments, you should see all of these lines coming up. And then we're going to open up a new terminal with Control-Alt-T. We're going to run ROS2 Turtlebot 4 viz viewrobot launch.py. You might have to give this a couple of minutes to load. This is where it gets a little bit annoying to deal with. There, that worked quicker than I thought. So the map data is showing up, but we're still waiting for the robot model to come in. And there we go. Not sure why that's still showing that it's red. Okay, so the purple and pink and red is the laser data. If we go over here into laser scan, we can change this from points to squares, so it makes it a little bit cleaner. All right, now we're going to open up a new terminal. We're going to run that teleop command from a while ago. This one, the keyboard twist. And as before, just give it a little bit of time to work. I'm just going to resume this when it's working. Okay, so now that it's working, it just takes a bit of time to work sometimes. We can see that I can turn the robot around. And if we look on the screen at the same time, it populates the data. Right. It sometimes gets a little bit messed up, but don't worry about it so much. So get approximately where it should be. In my particular case, it shifted for some reason, and I'm not sure why, but my robot is actually around here. So with that now done, I'm going to open up a new terminal. Let's see if it's in here. We're going to run, it's a little bit weird to do this, so it's ROS2 service call / slam toolbox / save map, slam toolbox srv / save map name. We're going to press the enter key, and we're going to press the space bar to add a space, and then we're going to name it robot 51 map 1, or whichever version it is, but I actually made a bit of a mistake. It's actually supposed to be data space, hold on, remember I said there has to be a space here, so it's data space single quote, end single quote, and then end double quote. You should see this, and then you'll get a success. If you don't, check that you did the right format of this command. Okay, so now that we have that, we're going to close out all of these other tabs, right? I mean, these other terminals and windows, right? So over here, we can close this. We can even close the keyboard command. Okay, so one of the files you're gonna, so if we go over here into the files, somewhere in here you will see robot 51 map 1, and you'll see the map that was generated. Again, it looks a little bit weird, but in my case, hopefully it'll look better for you. Now we are going to load that back into the software. So we're going to open up a new terminal with Control-T, and we're going to run this command: ROS2 launch Turtlebot for navigation localization launch.py, and we're going to specify map : equals robot51.map1/YAML. Make sure to say the same name that you did it as. We're going to press enter. You shouldn't see any errors, like shouldn't say abort. And then we're going to open up a new terminal with Control-T. We're going to open up the view robot in our viz again. So as you can see, the map loads. But we still don't see the robot yet, so we're gonna have to give it a moment for the robot to show up. So I'm gonna try to pause the video and we'll resume when it shows up. Okay, I tried something and I'm not sure if it caused it or if it just worked at the same time. You're gonna press 2D pose. Either way, you have to do this. So you're gonna do 2D pose estimate. You're gonna click approximately where the robot should be and drag it to whichever orientation it is. So mine's facing towards me, which is to the left on this map. And then that's that. As you notice, these are the points instead of the squares. However, this demonstrates what I was talking about, that the LiDAR is actually rotated by 90 degrees compared to what it should be. So yeah, we'll have that issue. If anyone does figure out how to rotate it in the software without physically rotating it, let me know. But ideally, you could then do nav2 goal and do a publish a point. I mean, sorry, not publish. Just click on somewhere on the screen to try to have it navigate there, but it doesn't really work. But one more thing we're gonna have to do, excuse me, is on a new terminal, we're going to do rouse to topic echo, I think it's /points. Okay, so we're going to do, hold on. Click point as close. So like that. And now, kind of move this like that, and if you do publish point and click somewhere on the screen, oops, not that, we will see what the point is. Alright, so what you're submitting for this assignment is one, the map that you generated. So it should show up in files. It's the one that ends in .pgm. So that'll be one thing. You're going to upload that to Canvas. And then you're going to take a video of this screen after you loaded the map in. And then back with the navigation, you're going to show that screen when you were moving the robot around and trying to navigate it, and you should try to go back and forth between the robot and the screen just so you can see all of it. Alright, and that should end this video.